Greetings to you. We are here with another session of advanced electronics training. And we want to continue the topic of resistors so that you become familiar with these concepts, just as we discussed fuse resistors in previous parts. And you have fully learned about fuse resistors and how to test them. Next, we want to talk about SMD resistors. This time we're talking about regular resistors, not fuse resistors. Here in this image, you can see several SMD resistors with different resistance values, and as an example, the calculated resistance for each one is shown below them. I intend to explain so that you learn how to determine the resistance value of these resistors. For example, you have an SMD resistor here that has the number 100 written on it like this. Always keep in mind to pay attention to resistors that are marked with numbers, only those that are numeric. The calculation is done in such a way to find out its resistance value. Look, the first digit is just itself and the second digit is also just itself. But the third digit, whatever it is, represents the number of zeros. So for example, if this resistor has the number 100 written on it, it means it's a 10 ohm resistor because the third digit is 0 and it doesn't add any zeros. Whereas this resistor, which is marked 101, means that it's a 1 followed by 10. So it's the first digit, which is itself, the second digit, which is 0. And for this one, the 1 means 10 is added. So 1 means 10, and the result is this, 100 ohms. Look at the next number. Here it's written as 221. So how is this calculated? The first digit is itself, the second digit is also itself, and the 0 at the end is counted as 0. So it becomes 220 ohms, meaning it's a 2, another 2, and if instead of this one, a 0 was placed, which means the same as this 0, 1 means 10, so it becomes 220, right? It becomes 220 ohms. Now, how do we know? Kilo. Ohms will be explained to you later. For example, here it's written as 102. Well, this 2 means that 2 zeros should be placed here, and you should translate this 2 as 2 zeros, which means 2 zeros. If this 0 is placed in front, how much does it become? 1000. So 1000 ohms. How much is that? 1 kilo ohm. So do you see? Here it is written as 1 kilo ohm. Look, 10 plus 2 zeros, you see? In this way, in the next part, it is written 4, 7, 2. Again, translate this 2 as 2 zeros. So it becomes 4700. It becomes 4700. In fact, it's 4.7 kilo ohms. Ohm, as written here, remember every 1000 ohms is 1 kilo ohm, right? So 4000 ohms is 4 kilo ohms and 700 means 700 ohms, which makes it 4.7 as written here. Here as well, you can see the number 103. Here, 102 was 1 kilo, but here 103 means 10 kilo. Why? Instead of this number 3, consider it as 3 zeros. That is, the number 3 indicates that 3 zeros are placed here. Well, if you add 3 more zeros, another 0 will be placed in front. That is, if this number is placed in front of 10, it becomes 10,000, right? 10,000. Oh, that means 10 kilo ohms, which we see here, and the rest as well. In the same way, for any number you see on carbon resistors, those that have numbers, it works like this. Carbon resistors are available both in numerical form and as a combination of letters and numbers, which we will learn about and discuss more in detail later. Those that are numerical are this simple and very easy to calculate, so the fixed number, you always consider it as the number of zeros. But the first and second numbers are always their own values. For example, here 47 is just 47 and this number 3 means 3 zeros. Consider that, which becomes 47,000 ohms or 47 kilo ohms. So it's 47 kilo ohms. And with fuse resistors, as you've noticed, the number 0 is always displayed, or sometimes no number is written at all. And just like that, you can easily calculate the resistance of SMD resistors. You could say that the first type of failure seen in circuits with resistors is, of course, when I say the first, I don't mean that all of them fail in this way. Well, it could happen in other ways too, but one of the failures I want to introduce here is this type of failure is called a burnt or visible state, meaning the resistor fails in a way that is visible. So much current passes through it that it burns out. As you can see here, it turns black or its color changes like this. Look, these resistors should all be roughly the same color. Well, but you can see that this resistor looks baked and dull in color. Of course, there are resistors that are colored by default, but how can you tell if it's burnt or if that's just its color? The first thing you should do is look at the resistors next to it, because usually in circuit board designs, resistors placed next to each other are within the same range and value. so they won't have any visible differences from each other. This is one of the techniques you need to use in repairs. So if you see, for example, there are 3 resistors and 2 of them are the same color, but the other one has a different body color and it looks baked like this, which is quite obvious. It means it's been exposed to a lot of heat and might be damaged, so it's better to replace it. Even if you test this resistor with a multimeter and it shows the correct resistance at that moment, it's still better to replace it. So my advice is, if you see a resistor whose color has changed like this, definitely replace it, even if it shows the exact resistance at that moment, because these resistors will have problems during operation. But when the device is off, it might show the correct resistance, and these are experiences we've had in repairs. Well, there's another type that burns out completely like this, and it's obvious that it's totally burnt. In this case, there's no need for any kind of testing at all, and you should just replace it easily. So you could say that one of the types of failures that happens to resistors is visible damage and burning. The second type of failure that can happen to resistors is what we call an open circuit, or being cut off, so to speak. This means that you take your multimeter, connect it to both ends of the resistor, and want to test the resistor. What's the result? You see that the multimeter doesn't show any value. It's like those fusible resistors where when you connected the multimeter, it didn't show any value and, well, it was open. This can also happen to a regular resistor with a certain resistance value, not just fusible ones. When you test it, you see that the multimeter doesn't show any value, as if there's no resistor there at all. This type of failure is one of the rare ones, but it does happen, and in this case, the internal connection between the 2 leads of the resistor is broken. Now, it has completely lost its conductive property and its resistance is extremely high, in the range of several megaohms. It has such a high resistance that it's considered open-circuited and is no longer useful for that circuit. So definitely keep this in mind. If you notice this during testing, that the resistor is actually open and the multimeter can't measure its resistance at all, you should replace it and use a new resistor instead, because in this situation, again, we repeat that this is called an open circuit or an open resistor. The next situation is the ohmic state or short circuit, which is also referred to as the ohmic state. Now, what does the ohmic state mean? For example, when you take a resistor and based on its color bands or its number, if it's SMD by the number, if it's LMD or a DIP resistor, in this way you identify its resistance value from the color bands. For example, you have a 1 kilo ohm resistor and you expect it to show 1 kilo ohm. You take your multimeter and measure it. Or you see that it's completely shorted and the multimeter shows 0. Look, there's a difference between showing nothing and showing the number 0. I talked about this in the previous session. 0 resistance, it shows or it displays a very low resistance, around 100 ohms. A resistor that should be 1 kilo ohm is showing 100 ohms. Or on the other hand, a resistor that should be 1 kilo ohm or its color bands indicate that it's a 1 kilo ohm resistor. Or if it's the type with numbers, the number shows that this is a 1 kilo ohm resistor. But when you measure it, you see, for example, 5 kilo ohms, 3 kilo ohms, or 2.5 kilo ohms, it shows a completely off value. This condition is also commonly referred to as ohmic failure. This means that the resistance value has changed. This happens because the material structure of the resistor has deteriorated, meaning its material has been damaged or there's a short circuit. Its conductivity increases and it can no longer limit the current anymore, or its resistance value becomes much higher than it should be. And again, well, this causes problems for a circuit, because if in a circuit and in a certain section, a 1 kilo ohm resistor has been placed, it's because at that point the resistor must definitely be 1 kilo ohm. And if it's more or less, it causes problems. So this is considered a type of failure and you need to replace the resistor in this situation. Now in the following, and to help you learn more, we will practically test the resistors, and after testing the resistor, we'll also cover how to remove different types of resistors like LMD, the same as DIP, and SMD resistors. We'll teach you how to remove them from the board, both with a heat gun and also by using a soldering iron to do this job. So you can fully learn how to remove other DIP and SMD resistors from the board. You need to know how to remove them or even how to perform the test, because we are going to do the testing practically again, especially for resistors that are SMD type. We'll also fully cover these SMD resistors, so you can learn all the material. After we've tested the SMD resistors and covered how to remove and actually desolder them, have we taught you about SMD resistors as well? Now we want to talk about package resistors and explain the method for identifying package resistors to you in a separate session. Stay with us for the rest.